I can show you one other way to add points to the pointing model. If you aren't able to use plate solve for some reason, maybe it's not finding a solution, or maybe it's taking too long to spiral out and find a match, there is another way that we can add points to the pointing model. So let's pick an empty region of the sky here, click and go to. We're starting with 0 points in the model, so our pointing is not going to be very good right now. And we, once we're on target, we can take an image with the camera. And then from here, you could take this image and use whatever other method you want to use to try to find the center coordinates of the image, whether that's the sky's image link or the astrometry.net web service. But say we solve this image and we find that the center coordinates in J2000 are some value, then we can type those in here and add it to the model using this button. So make sure that J2000 is checked and type in the coordinates of your solution. In this case, I happen to know it's 8 hours, 21 minutes, 27.4 seconds. And for declination, 33 degrees, 33 minutes, 44 seconds. So it's just hours, minutes, seconds, and degrees, minutes, seconds, separated by a space. And then click Model. And this window comes up again. I'm going to click Keep Window Up so that we can talk about the options. Again, the first time you probably want to do a simple offset init, or a sync, as it's otherwise known, which just jumps the crosshairs to point exactly at these coordinates without moving the telescope. So we'll do that first. Okay. And then we can go to another target, maybe nearby. So our pointing should be roughly accurate here close to this same region. We could take another image and plate solve it using our favorite method. And again, type in the coordinates of that solution, 841.51.1 in this case, and 3315.48. Again, J2000 should be checked because that's normally how these coordinates are reported. Click Model. And this time we click Load CalStar. That puts that point into the pointing model. We see we have 1 point now. And let's go to another point. Actually, let me stop that. Let's point away from any bright stars. Okay, take another image. Solve it using your favorite method, and this time I'll type in the coordinates 9, 17, 19.5, 6, 44, 31. I'm getting these numbers from the simulator that I'm using to run all of these tests, so I'm cheating a little bit, but you should get the same values if you actually run this through a plate solving program. And go to a third point. Oops, cancel. Click Go To. Wait until you're in position. Take an image. Solve it and type in the coordinates of the solution. 752.44 minus 9, 10, 56. Model. Load CalStar. OK. And if you do enough of these, you should eventually get to the point where PointXP is able to solve for your polar alignment error. And once you have that, then hopefully the built-in plate solve will work without having to spiral around too much to do a large search. If it still doesn't work, then you can go through and add more of these points manually as needed. Let me just try adding one more of these. So solution here is 10, 33, 51.3 minus 14, 02, 38. Okay, and now you see that our pointing model RMS has collapsed down because it has enough data to solve for the polar misalignment terms. And again, I'm using a simulator that's simulating 1 degree of up-down error and 2 degrees of left-right error. And with these 4 points that I just typed in, it's gotten both of those to within 8, 9 arc minutes or so. And if we were to add a few more points, it should converge on an even better solution. So that is another way to add points to your model if you don't want to use the built-in plate solve.